Okay, so we're going to be going. Are you calling from the? No, I wasn't calling from the bathroom. I was. What's going on, Algebra 2 students? Let's get this party started. We're doing the matching game exercise. I think this is actually some of your homework, but I'll tell you what. We'll do a couple of them for you. In fact, I'll tell you what. Why don't we even do it straight from the homework part for you? Because it's a warm-up, and I think it's a good one. I really like it. All right. Another thing, too, is I started class late. I started class real late. I thought that for some reason class in my mind was supposed to start at 1:30, but it doesn't. It starts at 12:45 on Wednesdays, and you're absolutely right. So what I ended up doing was my excuse is that I had to deal with another student in a different grade teasing another student, and we had to go down there and deal with the counseling and whatnot. So it slipped my mind to come up here and start the class. I apologize. That being said, I did say that I would give you free points if I were to start class late, and I'm a man of my word. So I'll tell you what. Look for that in the form of the teacher's comp grade. And that will probably go up at the end of today. Because this is the teacher compensating for being an idiot. Let's get this party started. Can you hear my voice all right? Can you see my computer screen? Man, and none of you folks said, contended me on calling myself an idiot. I guess you guys think that's true then, huh? Mr. Dodd is an idiot. And you guys like, yeah, pretty much. I'm not going to say nothing. Anyway, I'm just complaining. Don't worry about it. All right, so check us out. Let's take a look at your homework because I think this algebra review is straight out of your homework. And you know what? I don't even think you can see your homework. So I guess I should unlock it then. I think I still need to get all the answers in there correctly. But this isn't coming up until for a while now, so I have time to do this. Yeah, there we go. It needs... Let's see what the 3.1 homework is anyway. I need to put in all the correct answers. But I'm going to preview it so that way you know what to do when it comes up because it's going to be due on, later on. Okay, let's see. That graph... Oh, I just gave you the graphs. I didn't give you the things. Okay. Let's do it over here. So check this out. You have a bunch of graphs, and I guess what you could do is cut them out, but you don't need to cut them out because we can do it on the paper. And what we need to do is we need to match up the equation with the graph. Got it? So that's how that homework assignment is going to be. I haven't finished writing it, but I will. Let's try one. Let's try this one. Let's try graph number 3. Do you guys see graph number 3? Okay. What are the x-intercepts of graph number 3? One and 3. Close. -1 and 3. Absolutely. So if I have my y equals blank times blank, what's going to go in those blanks? There's going to be an x and an x, and there should be, what should I write in there? X minus 3, I agree. And x plus 1, very good. Because x plus 1 and x minus 3 translates to it crossing at 1 and 3. Got it? Now, technically, if I wrote x plus 1, x minus 3 over here, that would give me a graph that looks like this. What's the problem with the graph I just drew and the graph that we have? Exactly, I've got a happy graph and I need a negative graph. So how can I fix that? Well, at this point, I'm going to mess with the a. And you don't see an a, so I'll put an a. I know that this number is correct and I know that this number is correct. What I'm going to mess with is this number right here. And first of all, we know that that number is a negative number. y is equal to a times, or negative a times x plus 3 plus 1, x minus 3. Are we cool with that? There we go. Exactly. Put a negative in front of that first parentheses. All right. If I were to FOIL this out, I would get an equation that looks something like this. Y equals ax squared plus bx plus c. Right? If I were to FOIL this out. Okay. This c, what does this c do? The c will tell me, no, not the vertex. It tells me the y-intercept exactly. All right. In this particular case, we want this y-intercept to be what? We want it to be positive 6. Exactly. You can see from the graph, positive 6. So, what I want to do is I want to figure out what the number a is to let y equal positive 6. So you're talking about the y-intercept. You're telling me when x equals 0, right? So you're saying that y equals 6 when x equals 0. Is anyone confused about what I just wrote down there? Where I got it, where it comes from, all that kind of stuff. Okay. Yeah, what did I do? I wasn't here. Okay. What do you mean, what did I do? What did I do just now, or? Oh, okay. I'm doing a homework problem for you, and I haven't even assigned this homework because I think it's due on like next week. But this one I'm going to have it due, and we're looking at this graph right here. From the x-intercepts, we're able to get the graph. It looks kind of like this form right here. This is graph number 3, because we know that x crosses that positive 1 or negative 1 and positive 3. So we're able to get that form. But the thing is, we know that that's not the right equation because this would describe a happy face parabola. So we need to slap on a negative in front. In fact, maybe we might even need to slap on a number out in front. We don't know. So what we ended up doing is yes, we know that a has to be a negative number, but it could be a different number. Let's figure it out. So what I did was I said, all right, the y-intercept, there is a point that I can see that's on this graph. It's 0, 6. X equals 0, y equals 6. So I plug that into here, y equals 0, and x equals, or I'm sorry, y is equal to 6 and x is equal to 0. And I'm going to figure out what a is. Because I have an equation and I only have one thing that I don't know in that equation. So I put 6 is equal to negative a times 1 minus 3, or times negative 3. So that would be 6 equals a times 3. You guys see what I did? So a is, I think, Cameron, I agree with you. I think that a is, in this case, it's 2. And I see where you're coming up with a negative 2. It's because you're taking into account this negative up here. But I already took that into account. So you're right, actually, though, Cameron. In the end, a is negative 2. Essentially, what the equation for this graph would be is y is equal to negative 2 times x plus 1 times x minus 3. Are we cool with that? So then what I would do is I would go back to the graph right here and I would say, okay, graph number 3 corresponds to which equation? Which equation is graph number 2, or number 3? Yeah, we got the 6 from the y-intercept of the thing. D of x, let's take a look at d of x. It's 2x minus 2, x plus 1. No, not even close. We need an x plus 1, x minus 3, and a negative 2 out in front. The second column, which one is it? S of x, exactly. Oh, there's a second d of x? Ah. First of all, I have no idea why there's a second d of x. That's dumb. Second of all, that's close, but this d of x over here means that it crosses at -3 and +1. That graph is going to look like this. Whereas the graph we wanted looks like this. Does that make sense? No. I'm glad that you threw that out there. It makes sense, and I'm not going to make the same mistake as calling this thing D and this thing D. That's confusing. But do you see how to do this stuff? Is this all right with you? And I don't think it's new stuff. I think this is stuff we've learned, and if you haven't learned it, then I basically went through in pretty good detail how to do this problem. Yeah, I think that would be good. All right. Graph to symbolic. So what we're doing is we're trying to take a graph and we're trying to make it symbolic now. So what we want to do is, what I did was I gave you the equation before, and then I'm asking you to get the graph. And this time I'm giving you the graph and I want you to give me the equation. Sophia, the question is, why are we using the y-intercept to solve for A? And it's kind of like y equals mx plus b, and we knew what m was. Let's say y equals 5x plus b, and then we plug in an x and a y in our coordinate to figure out what b was. Does that make sense? We had to get a specific point, like 4, 3, and so we know that if x equals 4, then y equals 3. So we have 3 equals 5x plus b. I'm sorry, 5 times 4 plus 3b. Does that make sense? When I was choosing the y-intercept for this problem up here, all I was trying to do is find another point that I could see. Another point that I can guarantee that is on the graph. Because if I can find another point that's guaranteed on the graph, then I can graph it. I can see the equation much better. Does that make sense? So it didn't need to be the y-intercept. The y-intercept just so happened to cross this thing nicely, and that's the one I chose. For this one over here, I wouldn't use the y-intercept because I can't see what the y-intercept is exactly. I would probably use the point 1, 1. It's very similar to what we did when we were doing y equals mx plus b, but this time we're doing it with quadratics. Am I making sense to people? All right, so we're going to graph this, and we're going to see if we can figure out what the equation is now that we're given the graph. But how do I know 1, 1 is on the graph? It looks a little different. I'll be honest with you, that would have to be just a guess. I can't say precisely that 1, 1 is exactly on the graph. That I suppose is my assumption. Could I use the x-intercept? What I would be afraid of doing, Sophia, is up here I chose one point to plug in. So I have my equation, and then I took a specific x and a specific y and I plugged it in there. Does that make sense? The problem that I would be afraid of doing is don't choose one of the x-intercepts, even though you know that one of the x-intercepts, to plug in for your specific point, because you already kind of used that information up here. And so it's almost like you're double using that information, and things are going to fall apart. For example, if we said, okay, I know that 1, 0 is on the graph somewhere, and I plug that into here, then I'm going to have 0 equals negative a times 0 times negative 3. Well, this is 0 times negative a is equal to 0. The problem that I'm going to have, Sophia, is that this 0 times the negative a will kill off that a. And I couldn't tell you what a is specifically because all that information was destroyed when I multiplied it by 0. I mean, it's absolutely true that 0 equals 0, and that's good. But the problem is, it didn't tell me the vital information that a is equal to 2 that I wanted it to. Yeah. All right. So let's do this one right here. We have a graph, and our points are 2. Our x-intercepts are 2 and 4. So I would probably say y equals a times x plus 2, x plus 4. How's that?
Can I get lunch real quickly?
Yeah, what was your name again?
Maston.
That's right, Maston.
Yeah.
All right, you guys gonna come and hang out in here today?
I probably will today.
All right, for chemistry?
Yeah.
All right, good.
I just gotta wait till my
Yeah.
mom gets here.
Go get lunch.
All right.
All right. So, okay, wait, but the zeros are positive. Oh, you're right, absolutely right. I'm sorry, I messed that up. A times x minus 2, x minus 4. You're right. All right. And then we'll choose a point that we can find, and we don't want to choose the point that is a point that we already found. So I would say maybe 0, 0 comma 4. Yes, we can use 0 comma 4. We could also use 6 comma 4. Either one would work. It just has to be a point that we can nicely see. So 6 comma 4 or 0 comma 4, they both work. In fact, just to prove it to you, I'm going to use 6 comma 4. I know that that point exists on the graph. So I'm going to, just like what I did with y equals mx plus b, I'm going to replace the x and y with a specific value to give me my b. In this case, I'm going to replace the x and y with a specific value to give me my a. So I have 4 is equal to a times 6 minus 2 and 6 minus 4. So this would give me 4 equals a times 4 times 2. So 4 equals a times 8. So a is equal to 1/2. Very good. And if I were to write out my equation, it would look something like this. Y is equal to 1/2 x plus 2 x plus 4. You guys got it? All right. Let me actually try to do something else. What if instead I chose the 0 comma 4, which is the one we thought we were going to do? I wonder what would happen. And Lucas, ask your question while I'm doing this. I'm going to plug in 4 equals a times negative 2, because 0 minus 4, or 2 is negative 2, times negative 4. Oh, you're right, Lucas. I'm sorry. There's supposed to be minuses on that thing. You're absolutely right. I'm sorry. I don't know. I guess my brain might be off. All right. So check this out. What happens if I did a different point? What if I use 0 comma 4 instead of 6 comma 4? Well, what I would do is it would be 4 equals a times 8. A is equal to 1/2 again. It's the same constant. So, you know, Sophia, when you were asking me, why are you using the y-intercept? Why are you using the y-intercept? And my answer is just because it's an easy point for me to see. If it weren't an easy point for me to see, I wouldn't use it. I just need to find an easy point where everything crosses nicely, and then I can say, okay, that's the point I choose. Can I give you one last note about this problem? Is everyone cool with getting here? Okay. I might ask you to, when I ask you to answer this question, I don't know how to tell you to type into the computer 1/2 x minus 2 x minus 4. I don't know how to do that. But what I might do, and I haven't finished writing this homework, so I mean, I'm just letting you know I'm off the top of my head. What I might do is I might have you FOIL everything out, like 1/2 times x squared minus 4x minus 2x plus 8. X squared minus 6x plus 8. And then distribute that 1/2, and so I have 1/2 x squared minus 3x plus 4. All I did was I FOILed everything out, so I wrote this same exact equation. The difference is this one's in standard form. Do you remember I talked to you about standard form? Alright. I have my class. My sister asked me if the class is live, and if I turn my mic on, will everyone be able to? Yeah, I think so. I think everyone can hear you if you turn your mic on. All right. Does everyone understand how I got here? All I did was I FOILed it. Okay. Yeah. The way I might have the computer ask you this answer is I might ask this question in 3 parts. And I might say, compare it to the standard form, ax squared plus bx plus c. The a is the number in front of the x squared term. The b is a number that has an x next to it, and the c don't got nothing to it next to it. And all you have to do is tell me what a is, which is a equals 0.5, b equals -3, and c equals 4 for this problem right here. So, when I ask you to input the answer, what I'm going to ask you to do, what I will probably ask you to do, is I'll give you a graph, and then I'll say, put your answer in standard form, which means you have to get to this part, and then go to this part over here. And then once you get your answer, you'll be able to read your A, B, and C off to me. And you can tell the computer 0.5, -3, and +4. That's my answers. And I'll ask the question in 3 parts. Does that make sense to you now? All right, cool. Let's move on. Okay, let's do this one. Find the symbolic representation for a quadratic function f, whose zeros are x equals -1 and x equals -3. And the y-intercept is 0, -6. Let's see. If the zeros are at -1 and -3, if I were to draw this graph, maybe sometimes it's easy for me to start off drawing the graph. The zeros are at -1 and -3. Here and here. And the y-intercept, he said it was at +6. So way up here. All right, I agree with Sophia. I would say that my equation is equal to x plus 1, x plus 3. We're good there. We're in agreement there. And then for a specific x and y coordinate that they gave me, I can definitely say that 0, -6 works. So if I plug x equals 0, y should equal negative 6. Zero plus 1 is 1, and 0 plus 3 is 3. That's why I wrote that there. So this is negative 6 equals 3a. So a is equal to negative 2. So actually, I messed this graph up. This graph actually should be going this way. Because the y-intercept was negative 6. Yeah, I made it happy to begin with, but I think it should actually have been a sad parabola. There we go. That's how you do it. All right. This is it. How do you feel about this homework set? Are you going to draw? No, you're not going to draw any parabolas. I think what it is I give you the parabola, and this time, so before I gave you the equation, and then you drew the parabolas for me. And this time it's going to be backwards of that. I'm going to give you the parabola, and you give me the equation for it. Okay. This one looks hard enough. Let's try this one. Find the symbolic representation of the following quadratic function and determine both the coordinates of the vertex. All right, this is a little bit harder, but let's do it. What are my x-intercepts? Negative 3, positive 1. I agree. So Sophia's already on top of it. Let's see. Y is equal to a times x plus 3, x minus 1. Does anyone have any questions about that? Okay, good. Now, tell me a point that is on this graph. Negative 2 comma 0. Actually, Lucas, Sophia's right. It's 0 comma negative 2. Ethan says 1 comma 0. Yes, you're right, Ethan. 1 comma 0 is a point on the graph, but it's the y-intercept, and we've already used that information. So if I use that information again, it's basically going to like cancel itself out. Yes, you can't use the y-intercept again. So 0 comma negative 2, I agree. You could also have chosen negative 2 comma negative 2. That would have worked. But 0 comma negative 2 works perfectly fine as well. That means if I plug in a 0 for the x button, then the y button should pop out a negative 21. So I have y equals, wait, did I say negative 21? Dude, I must be really tired. I'm sorry. The y is negative 2 equals a times 3 times negative 1. Does that make sense? All right. Sophia, you suggested that the vertex is negative 1 comma or 0 comma negative 1. No, that's not the vertex at all on this thing. The vertex is actually negative 1 comma like negative 2.7. Oh, okay. So the way we figure it out, though, is we can say, well, a is equal to this, and so negative 2 equals a times 3, or negative 3. So a is equal to 2/3. Does that make sense? So if I were to write out my equation, it would be y is equal to 2/3 x plus 3, x minus 1. I'll tell you what, we're going to do a few things with this equation, I don't think that that was so bad. What do you folks feel about that? All right. I'm going to do a few things with this equation. I'm going to FOIL it out so I can put it in standard form because right now it's in factored form. All right, so let's do 2/3 times x squared minus x plus 6x minus 3. Then I have 2/3 x squared plus 7x. Oh, 7x minus 3. So if I distribute this thing in, that would be 2/3 x squared plus 14/3 x minus 2. This is the standard form of that equation. How's that? Did I screw something up? Let me see. You're absolutely right. Man, I am just bombing today. I don't know what's going on. Negative x plus 6 is negative 5x. So this should be a... No, it's positive 5x. So this should be a 10 over 3. Whew. Yeah, sorry about that. Are we cool with this? Does that make sense to you now? So I think if I were to ask you what is the answer for A, B, and C, you would tell me 0.667, and then this would be 2.667, or no, 2.333, and negative 2. All right, let's keep going with this thing, and we'll do this. If I were just given the equation without knowing the what the graph looked like, I can find the vertex pretty easily. How do I find the x-coordinate of the vertex? I averaged the zeros, exactly, and the zeros were negative 1, negative 3, and positive 1. So negative 3 plus 1 all over 2, that's negative 2 over 2, which is negative 1. Are we cool with that? Yes, there should be a margin of error for you folks to put in different answers and it still give you points for it. All right, so we know the x-coordinate is negative 1. What is the y-coordinate? Well, all you do is you take that negative 1 and you plug it back into your equation because you're given that y is equal to anything and that depends on x. Well, the x that I'm looking for is negative 1, so I would say 2/3 times 2 minus 2 times negative 2. You guys see where I got that? Let me know if you get confusing, or if you get confused. Ugh. Excuse me. All right. Let's see. It says plug in negative 1. Did I fix all of my mistakes? I put the negative 1 back into the equation. Oh, yeah. Are you asking me what I did? Yeah, I took this negative 1 and I put it back into this equation right here. Because I want to figure out a specific y value that corresponds to that x equals negative 1. Yes, I'm recording this, and this is probably one of the most embarrassing classes because Mr. Dalde is just, I don't know what it is. I feel like somebody drugged me or something. I'm tired. Oh, yeah, you're right. I forgot to record it in Canvas, but I think I restarted the recording. Yeah, I recorded the YouTube. I didn't record the Canvas. That's just the way it's going to go. No one ever watches the Canvas recordings anyway, or at least I don't think they do. The YouTube ones is the ones I actually have them watch. Yeah. All right. Let's multiply this out. Let's see. That would be negative 8 over 3. which is the same as negative 2 1/3, or 2 2/3. Are we cool with that? So if I were to ask you, where's the vertex of this thing, you would have to tell me -1, negative 2 2/3. Or if I were to ask you in terms of like decimals, you would have to tell me -1, negative 2.667. All right. If we look at the graph, -1, 2.667. Do you guys agree that that would be where the vertex is? Awesome. Yeah, I guess you could write 6667. Yeah. All right, cool. Moving on. Technically, I started class about 1, and we're supposed to only go for about 40 minutes. Is it cool if we end here? Because actually, I think I got to go up to 3.5, or I'm at 3.5, and there's only 3.7. You go up to 3.7 for this homework, or for this whole thing. So I'm not too far off from finishing halfway through yet. So if it's all right with you, I think I'll stop here. Yep. All right. I'll talk to you later. Give me a second. Let me stop the recording.